So section 4.6 is about solving polynomial inequalities. Well, we remember how to solve polynomial equations, right? If the polynomial may be with the degree 2 or higher. But now this section will take a look at solving inequalities where the expression is a polynomial function or is a polynomial expression. Now, the first thing that you want to do is you want to, when you're looking for the solution of an inequality, where you have a polynomial function, it's going to be whether you are looking for when the expression is greater than 0, expression less than 0, greater or equal to 0, which will include the values for which it equals 0, or less than or equal to 0. Also, the two last situations will be when the expression equals 0 and greater than 0, equals 0 or less than 0. This will always imply solving expression equals 0. Well, we will always want to know when the expression is equal 0. So we want to know, to find out this and then decide with techniques or checks where the expression will be less than 0. You know, less than 0 meaning that the expression takes a negative value over a certain interval, and when the expression is taking the positive sign over a given interval. So first of all, we're gonna want to find out when the expression is equal to 0. So we will solve expression equals 0. So let's start with the expression that we have, x squared plus 3x minus 18 is equal to 0. So that's what we're going to solve first. When we find those values, we will discuss with the sign of the expression. Now, this expression in factored form will be x plus 6 times x minus 3 equals 0. And when we use the 0 product property, we will have x plus 6 equals 0, or x minus 3 equals 0. So two solutions will be found: x equals -6 or x equals +3. Now, what we're going to do here is we already know when this expression will be equal to 0. Now, we will place those values on a table that we will be able to study the sign of this expression. So let's consider that for all x values taken into the x values for as a real number. So everything here would take into consideration. It would be taken into consideration from -infinity to +infinity. But let's take some stops at the values x equals -6, x equals +3, where the expression is equal to 0. So we're going to take for -6 and 3, x equals from -infinity to -6, and from -6 to +3, and from +3 to +infinity. So you see how I'm going to identify some values in each interval. So we have those intervals. So let me show my intervals. So we have one interval from negative infinity to negative 6. Well, we're gonna put bracket because 6 is included. The reason we say that 6 is included because we are solving not only for less than, we're looking for when the expression is less than 0, but also including 0. That's why we can include the values at which the expression is 0. So we have this interval. We also have another interval from negative 6 to positive 3. From negative 6 to positive 3. And we also can take the interval from positive 3 to infinity. So these are the 3 intervals that we will work on, and we're going to see which one verifies the condition set for this inequality, which is whether the expression is less than or equal to 0. Now, to do so, to identify which interval works, we're going to take some values from each interval. And whatever the expression is, the sign of the expression for the test value, and it's going to be the same for any value taken into this interval. So let me find a value from negative 6 from negative infinity to negative 6. Well, I always want to take values closer to negative 6 because the bigger the value is, the less, the more work you're going to need to do in order to solve it. So that's why I will take the closest value to negative 6. Well, I can take negative 7. Negative 7 is between negative infinity to negative 6. And then from negative 6 to positive 3, since you go from a negative number to a positive number, that it means 0 would be inside of this interval. And it's always better to take 0 because it will make it easier for you to plug in 0 and find a value. And also, I can take a value from 3 to positive infinity. I take the closest integer to 3, which is 4. Now, for each value, when I plug them into the expression x squared plus 3x minus 18, I'll be able to find a number. When you plug in the values, negative 7, 0, and 4, each of them will give me a value for the function, which will have a sign. And the sign of those values will indicate the sign of the expression over this interval. So for negative 7, when you plug in negative 7, you will find x. When you plug in negative 7 into x squared plus 3x minus 18, you get negative 10, actually positive 10. 0, when you plug it in, it's negative 18. And when you plug in 4, you get a positive 10. Now, let's try to see what we get here. Because those values will indicate the sign of the expression x squared plus 3x minus 8 over each given interval. That means the expression x squared plus 3x minus 18 over the interval from negative infinity to negative 6, it tells me that this expression is positive. It's positive. And then over the interval negative 6 to 3, it's negative. And over the interval 3 to positive infinity, the expression x squared plus 3x minus 6 minus 18 is positive. And we should remember that we were solving for the expression to be either negative, or equal 0. So positive will not be considered. So basically, we should reject this interval. We also need to reject this interval because the expression is positive over this interval. And then the only consideration we're going to make is that this will be taken. And then your solution here will be from -6, solution is from -6 to positive 3. From -6 to positive 3. Okay. So we have the solution here that is from -6 to positive 3. We include the values because negative or equal 0, and -6 and 3 are the values for which the expression is 0. So to graph this solution, -6, we put a closed circle here because -6 is included. To positive 3, also close circle because those values are included. We're solving for this expression also equals 0. And then it will be negative over the interval from -6 to positive infinity. I mean, to positive 3. This will be the graph of the solution. Our next example is the same concept. 9x squared plus 5 plus 7x less than or equal 0. We're going to solve to see where this expression is equal 0 or less than 0. Now, the basic information that we need to know is that sometimes when solving these type of equations, we're going to want to solve the equation 9x squared plus 7x plus 5 equals 0. So that's where we start. Now we need to understand and remember that sometimes when solving these type of equations, we find this expression never equals 0. Never equals 0. So sometimes this will never be 0. And this happens when the expression b squared minus 4ac is less than 0. So when a squared minus 4ac is less than 0, this expression has no solution, no real solution. So if we say that if b squared minus 4ac less than 0, then then we have ax squared plus ax squared plus bx plus c equals 0 has no solution. So that has no solution, meaning that the expression is never 0. This expression ax squared plus bx plus c will never be 0. So you have two cases. It's either ax squared plus b plus bx plus c greater than 0, or ax squared plus bx plus c is less than 0. Now we know that it is greater than 0 if a if a if a is greater than 0. A is the coefficient of x squared, a. If a is greater than 0, and if a it's less than 0, if a is less than 0. That means when the expression b squared minus 4ac is less than 0, then we have two situations. I mean, we have three things that happen. First, we have the equation ax squared plus bx plus c that is 0, that is never 0. It's never 0. And then the other situation is that the sign of ax squared plus bx plus c will be the same as the sign of a. If a positive, then the expression will be always positive, which means the solution will be all greater than 0. So if you are solving for less than, it will be no solution. If you are solving for greater than, it will be all real number solution. And then if you were solving for the expression less than 0, and the sign is less than, like the sign of a is less than 0, the expression will be always negative, and then you will have all real number solution. And if it's greater, if a greater than 0, you will have no solution. So when b squared minus 4ac is negative, you can either have all real number solution or no solution. Depends on what equation you're solving. So the summary of everything that I just said is this. For a quadratic equation, x squared plus bx plus c equals 0, the solutions are given by x equals negative b plus minus square root of b squared minus 4ac over 2a. And if a squared minus 4ac, the expression inside of the radical, is less than 0, the quadratic equation admits no real solution. And the quadratic expression ax squared plus bx plus c preserves the sign of the coefficient a, meaning the number that is the coefficient of x squared. Now, what we're gonna do first here is that we're gonna find the number we're going to evaluate, b squared minus 4ac. We're gonna try to see what it equals to. We know that a equals 9, b equals 7, and c equals 5. Now, b squared will be 7 squared minus 4. A is 9, c is 5. So b squared minus 4ac equals to negative 131, which is less than 0. Now, because it's less than 0, the expression 9x squared, the expression 9x squared minus 4 minus plus 7x plus 5 is positive, is positive because the sign of A, because A equals 9 is greater than 0, and we know that the expression takes the sign of A. So now on your table, you know that you're going to have this consideration for all the x values. All the x values are going to be from negative infinity to positive infinity, and all of them will be positive. All of them will be positive because we already know that the sign of A equals 9 is positive. A equals 9 is positive. So we have the sign of A for the expression 9x squared plus 7x plus 5. Now, we will remember that we were solving for x is less than and greater than 0. We have no case where the expression will be either equal 0 or negative. That means there will be no solution for this consideration. So 9x squared plus 7x plus 5 less than or equal 0 has no solution. It has no solution because we find a situation where the expression will always be positive. There will be never a case where it would be equal 0 or less than 0. So you have no solution, and your solution is the empty set. Solution is the empty set. So we have no solution. So this next example will be the same consideration that we have. We're going to solve the equation. We were solving 4x squared minus 5x. I'm trying to organize the terms, plus 8. We are looking for where it's greater than 0, greater or equal to 0. Well, that's the condition set for this inequality. And now we know this type of inequalities, we need to find where it equals 0 first, and then discuss with the sign. So we're going to want to solve the equation 4x squared minus 5x plus 8 equals 0. Now, we're going to test to see if this equation is whether it has solution or not by finding the sign of b squared minus b squared minus 4ac. B squared minus 4ac. We're going to find it. Remember, here we have A equals 4, B equals -5, and C equals 8. So -5 squared minus -5 squared minus 4ac minus 4 times A equals 4, C equals 8. So we calculate this, and then we get the 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 expression negative b squared minus 4ac equals negative 103, which is less than 0. So the expression is taking the sign. So 4x squared minus 5x plus 8 takes the sign of a equals 4, which is positive. So it's always positive. We have 4x squared minus 5x plus 8. That is always positive. Always positive means it checks the box for this, because you are looking for where it's positive or where it's equal 0. And if we find it equal, always positive, so that verifies if it's either one or all of them or both of them, positive or equal 0. If it's positive, the box is checked. If it's equal 0, the box is checked. But we find it not equal 0, never equal 0, but we see that it's always going to be positive. So the sign, if we take the same table that we use here, we will have an expression that will be always positive, in contrary of the first problem that we solved, that was so positive, which checks the whole box, because that's what we were looking for. So we have the expression 4x squared minus 5x plus 8, 4x squared minus 5x plus 8, that is always positive. So your solution will be all real numbers. All real numbers are solutions. So that means solution equals from negative infinity to positive infinity. So this next example is similar to those we've already done. So we're gonna reorganize the terms. 3x squared plus 27x plus 42. We're solving the inequality less than or equal 0. Now, because when I'm looking at all the terms, they have a common factor that is 3. I can divide the terms by 3 to clear the common factor. So that's going to be x squared plus 9x plus 14, which said less than or equal 0. Now, we can check to see if when we consider A equals 1, B equals 9, and C equals 14, if we calculate, we can try to calculate B squared minus 4, B squared minus 4AC, 4AC. We can try to find it, but obviously we can try also to see if we can find 2 factors of 14, that the sum is 9. And I see that I can, and that will tell me obviously that this will be greater than 0. Because if B squared minus 4AC greater than 0, you'll be able to find the 2 solutions. That's the only reason we would want to find this expression. But if you already have 2 factors of 14 that the sum is 9, you already know that we have solution which will imply that this expression is positive. So that said, we can write it as x plus 2 times x plus 7, where 2 times 7 is 14, and 2 plus 7 is 9, equals 0. To find the two values that makes this expression equal 0. So x plus 2 equals 0, or x plus 7 equals 0. And then we can subtract 2 on both sides. X equals -2. Subtract 7 on both sides. X equals -7. We have two values for which x squared plus 9x plus 14 is 0. So those two values are the values for which we have 0. Then we can set up the table. Can set up the table to evaluate the sign. So that's x, and that is the expression 3x squared plus 27x plus 42. We will try to see where it's positive, where it's negative. So from negative infinity to positive infinity, we have two values for which it equals 0. We have -7 and -2. And inside of each interval, we're going to try to find a value for which we can evaluate the sign of the expression over each interval. So let me take -8 here. I will try to take -3 inside of this. And then from -2 to infinity, I'll try to take 0 to make it easy for me. Now we will evaluate the expression 3x squared plus 27x plus 42 over each interval for x equals -8, x equals -3, x equals 0 to see what will the sign be for each interval. So for x equals -8, -3, and 0. For x equals -8, we have 3x squared plus 2x plus 42 equals 18 when we plug in. And for x equals -3, 3x squared plus 27x plus 42 is -12 when we plug it in. And when we plug in 0, 3x squared plus 27x plus 42 is 42. So we see that, remember, we were solving only when the expression is less than or equal 0. So the intervals that we have are from -infinity to -7. We include -7 because -7 makes the expression equal 0. So we have this equals 0 for this. And then we also have the interval from -infinity to -3, including -3 and -7. And also we have the interval from -2 to infinity, are the three intervals that we are evaluating the expression 3x squared plus 27x plus 42. Well, we see that we cannot take this interval -infinity to -7 because we're looking for when it's negative, it's positive over this interval. We can't take -7 to -3 because the expression is -12, and we're not taking -2 to infinity because the expression 3x squared plus 27x plus 42 is positive over this interval. So the solution here is from -7 to -3, because that's the only interval that gives me 3x squared plus 27x plus 42, either negative or equals 0. So that is from -7 to -3. And the graphing of this solution will be -7 included and -3 included, and then everything in between. Everything in between. So that is the solution for this problem. Well, this example will be similar to the ones we solved already, but the only difference here is that we have a polynomial of degree 3. So we would expect a minimum or maximum of 3 solutions, but we're still going to break down the number line as we have the solutions and study the sign of the expression 2x to the third plus 44x squared minus 2x minus 4 over the intervals, and then take the only intervals where the expression is exactly strictly negative. We're not taking when it's positive. We're not taking when it equals 0. So we want to first solve the equation 2x cubed plus 4x squared minus 2x minus 4 equals 0. We want to see where it equals 0 so we can break down the number line with the solutions. So I realize that we can factor by grouping here. Let me go ahead and factor by grouping. So the GCF of the first group, which are the first 2 terms, will be 2x squared, and that's x plus 2 minus 2 x plus 2 x plus 2 x plus 2 x plus 2 equals 0. We factor x plus 2 again. Well, we keep 2 on the outside, and then x squared minus 1 equals 0, which is 2 x plus 2 x plus 1 x minus 1 equals 0. So we will have 3 solutions: x plus 2 equals 0, or x plus 1 x plus 1 x plus 1 equals 0, or x minus 1 equals 0. So we have x. If we subtract 2 on both sides, x equals -2. If we subtract 1 on both sides, x equals -1. If we add 1 on both sides, we get x equals 1. We're going to create a table to study the sign of the expression. So that's all the x values from -infinity, from -infinity, -2, -1, +1, and infinity. The expression is 0, expression which is 2x, expression is 2x to the third, 2x to the third, plus 4x squared minus 2x minus 4 is 0 when x equals -2, 0 when x equals -1, and 0 when x equals +1. So now what I'm going to do is I'm going to look for some values over each interval that will be used as testing values to see what the sign of the expression will be over each interval. So I'll take -3 here, which is over the interval -infinity to -2. I will try to take -3 halves from -2 to -1. I will take 0 because 0 is inside of the interval -1 and 1. And I will take 2 for the last interval. And when I take those values, I will evaluate, plug in these values and evaluate the function, the expression for each and find out whether the expression is positive or negative for each interval. Now, for the interval -infinity to -2, when I plug in -3, the value is -16, which is an acceptable value because I'm looking for when it's negative only. So we take this value. When I plug in -3 over 2, I find 5/4, which is positive. So this is not acceptable because I'm looking for values that are when the expression is negative. And when I plug in 0, the answer is -4. This one is okay. I can take it. It verifies the conditions. And then the last one, when we plug in 2, if 2x cubed plus 4x squared minus 2x minus 4 is 24, which is not acceptable because I'm looking, which is positive, and we're solving when it's negative. So we are not taking the interval from from 1 to infinity. So our solution here will be this interval and then this one. That means solution will be from -infinity to -2. We're not taking the -2 value because we're strictly solving for x for the expression less than 0. So, and then we also taking the interval from 2 from -1 to 1. And we're not taking the values because those values make the expression equal 0. We are only taking when it's negative. So that makes it clear for you that if you put parentheses when you need to put intervals, or I mean brackets, if you put parentheses when you need to put brackets and brackets when you need to put parentheses, your answer will be wrong. And don't say, oh, I only forgot to put bracket and then I put parentheses. No, your answer is wrong because you cannot put parentheses when it requires for you to put bracket. So you can't switch them. If you don't put the right thing, your answer is incorrect and you can't get the credit for it. So the solution here is from -infinity to -2, union from -1 to 1. And if we want to graph this solution, we're going to have an open circle on -2. It's open on -2. Open on -2. Open on -2. Also open on -1. Also open on 1. And it's going to be from -infinity to -2. And then from -1 to +1. Okay, so let's try this last example here. So we're solving for this expression, but because we have a quadratic expression, we want to move it on one side and then zero this inequality out so we can compare to zero instead. So that's going to be 8x squared minus or plus, we move it over, we add 2x squared and 12 on both sides of the inequality. So that's 20, we add 22x squared plus 12 on both sides of the inequality. So that's 22x plus 12. That is less than 0. We want to solve it equals 0 first. So that's 8x squared plus 22x plus 12 equals 0. Since we see that 2 is a common factor, we can divide all the terms by 2, then get 4x squared plus 11x plus 6 equals 0. We're going to solve this. We can multiply 4 and 6, that's 24. We need two factors of 24 that the sum is 11. So that's 8, 8, and 3. 8 and 3. So the sum is 11. So I can factor this, the right side of the equation as, left side of the equation as 4x squared. I can rewrite the left side of the equation as 4x squared plus 8x plus 3x, which is the 11x that we had. Just I break it down to 4 terms so we can have 4 terms and factor by grouping, plus 6 equals 0. First group, second group, factor 4x on both sides for the first group. So that's x plus 2. Factor 3 on the second group, x plus 2 equals 0. Then I will refactor x plus 2. Then that's 4x plus 3 equals 0. Use the 0 product property. So that's x plus 2 equals 0, or 4x plus 3 equals 0. Subtract 2 on both sides. X equals -2. Subtract 3. 4x equals -3, and divide by 4. Divide by 4. So we get x equals -3/4. And then we can go ahead and set the table so we can study the sign of the expression. So we get x, and then you have the expression 8x squared plus 22x plus 12. That's the expression we're trying to study its sign. And then the numbers vary from -infinity to +infinity. And the solutions were -2 and -3/4, right? Then we're gonna try to find a number on each interval so we can evaluate this expression to see where the signs, what the signs are for each interval. So let me take -3 over the interval from -infinity to -2. Let me take -1 over the interval from -2 to -3/4. And then I'm going to take 0 over the interval -3/4 to infinity. And then when I plug in those values into the expression 8x squared plus 2x plus 12, when I plug in those values, I see that the expression is 9 for x equals -3. Replace x by -1 in the expression 8x squared plus 2x plus 12. We have well, maybe it's 18 here. It's 18. Say 18. Uh, 18 -2 and 12 when we plug in. Then we only consider the one that's negative because we were solving for the expression to be less than 0 here. So your solution is and we're not including the values because we're solving only when it's less than 0. So we have from -infinity to well, -2 to -3/4. And we're not including them. So solution is from -2 to -3/4. And then on the number line, we can sketch the graph. It's from -2 with an open circle to -3/4. -3/4, 3 is 0.75, will be somewhere between -3/4 will be from a quarter way from -1 to 0. Be around here. And then we can sketch. It's closer to 0. And then we can sketch the solution here. So that is the solution for the inequality 8x squared less than 22x minus 12.